Welcome back everybody to the world's greatest Java tutorial series. This video we are going to be talking about collections, and if you're just jumping in, you can follow my Git repository. It's github.com/Caleb Curry/30 days of Java. And if you're wondering what commit we're on right now, we are on, this is the last one, so we're going to add after that. And what are we going to be doing? We're going to be talking about collections. So we started our discussion of collections in the previous day or previous tutorial, and we really only covered arrays and lists. But now I want to look at collections a little bit more broadly. So talking about the different options. And this is, some of it I know, but some of it's also a learning experience here. So we're going to do some exploration and hopefully have a little bit of fun. Crazy, I know, but we'll try. So if you're just jumping in, that's fine, but I'm going to reference the previous video just a little bit, so pay attention if you're new. In the previous video, I explained how on the left side we use a list, and then when we're actually creating an instance, we use ArrayList. And I briefly mentioned that this is because on the left side you can use an interface, and on the right you use a specific implementation of that interface. And I wanted to dissect that a little bit more in this video because I didn't really talk about it. So let's look into that and see what that really means. Essentially, the interface defines certain things that things must do, right? So an array list must meet the requirements of a list. So it's basically a list of things that must be met. And I want to see if we can find a good chart of all of the different interfaces when it comes to collections. And a list is just a specific type of collection. A collection is just a word to describe anything that we can store information in. So collection is more broad than an array list. An array list is a specific type of collection. So I'm using this book here, Core Java, and there's a good illustration right here of some of the different collections. But I'm hoping to find one online that I can share with you guys. And we'll either look at Geeks for Geeks or Oracle Docs. I like both of those websites. And here, this class is a member of the Java Collections Framework. Let's take a look at that, see what's in there. Go to Overview of the Collections Framework. And hopefully I can scroll in just a little bit, it's a little small. All right, cool. So it reduces programming effort, increases performance, all these things. I mean, obviously, people wouldn't use it if it wasn't decent, so I'm not going to go through here's all the reasons you want to use it. But one thing in here is that there's collection interfaces, and these represent different types of collections such as sets, lists, and maps. These interfaces form the basis of the framework. So we have some basic interfaces, and then we have various implementations of those interfaces, which are specific examples, similar to how we can have a list interface and then an array list implementation. So let's scroll through here, and it's too zoomed in now. Let's see what we can find. All right, so here are some collection interfaces. And you can see we have set, and then there's a couple other sets here. We have queue, and then we have a couple other queues here. Then we have a DQ, blocking DQ. Then we have map, a couple other variations of map, and so forth. So it says here that the maps are not true collections, but it contains collection view operations, which enables them to be manipulated as collections. So in other words, I have no idea what that means. But essentially we can use maps similar to how we use all the other collections. Let's check out the Geeks for Geeks article and see what we can find. So we'll search collections Java and go to this first one here, Geeks for Geeks. Hopefully there's some pretty pictures because that's what I like. Oh, pictures? Yeah, this is pretty similar to the illustration I showed you in the book. These are the interfaces. Pop-ups. Oh, let me tell you what. All right, so these are the interfaces that the collections in Java are going to implement. Notice how map is kind of over here by itself, which correlates to what I was just saying from the Java documentation, how they're not true collections, but they're similar in nature. I guess we'll figure out a little bit more about why as we go on, but you can see there is a common interface here, collection. So all of the collections are going to implement this interface. So I want to see if I can find some information on this collection interface, maybe get a little bit more details of what it requires from the implementations. So I just searched Java collection interface, and we're going to look in the documentations from Oracle, so collection. And you can see that this is an interface. So we're on the right page here. And here are the implementation classes. So all of the different implementations. So the things on the right, going back to our code, that would be the stuff over here. All of these are examples of things that implement collection, which you could use on the left. So instead of using list here, you could, in theory, say collection, and then import collection java.util. And voila, things still appear to work. But I tend to stick with list or just using ArrayList on the left. You can do that as well. So instead of collection, you could just say ArrayList, which is usually going to work just fine. And you can look up the differences on the internet. When you're working with a local variable, like students here, it doesn't really matter a whole lot what you're going to use here. I would probably just use ArrayList. I think that's fine. But when you get into class level variables, so for example, if you create a variable up here in the class and you say list, let's just copy that one. We'll just do it like this. And then let's say you make an instance of this class. You can use anything that implements list. So we haven't really talked a whole lot about object-oriented programming, so don't worry about it too much, but just pay attention here. And what you can do is you can say, inside of this method, you can say my sweet program, we'll just call it P, and then we'll say new my sweet program and give it parentheses. So that's how you create a new instance of this class. And what we're going to do is we would say p dot stuff, and you can assign this an array list of type string, like so. And it looks like we're not getting any compiling errors. There's a warning, but that's just because we still have this java.util.collection. So don't worry about that. So this works because ArrayList implements list. But if you go in here and let's say we get more specific and say you have to have an array list, and then we try something like new linked list, we're going to get an issue here. You can see it says we have to import it. So make sure you import that. And you can see there's a type mismatch. So basically we're trying to assign something specific to something specific, and they're not the same things. Cats are not dogs, even though they're both animals. So you can think more generally up here and just say, hey, we want anything that accepts that implements list. And in this situation, linked list would work just fine. You can even be more broad and say, we want anything that implements collection. So that is how interfaces work. And when we get into more advanced object-oriented programming, when we create the class level variables like we're doing here, where the variable is not defined inside of a method, it's defined directly inside of the class as its own member, then you might want to make those a little bit more general using an interface rather than a specific type such as linked list or whatever it might be. So hopefully you don't feel like we just jumped into the super deep end and I left you to drown. I don't want you to drown, so let's dissect this a little bit and let's learn together, because I got lots to learn about this myself. So let's just go back to what we had, just getting rid of that and getting rid of that. I just wanted to type that out just to experiment. That's not actually going in our code. So clean up our code here and we can get rid, let's just keep the import statements because we might end up using those and I don't have to click import every single time. So local variables, it's probably fine to use an array list directly here because that's really the only place it's going to be used. I was just showing that you could use list on the left here in the previous video just for the sake of explanation. If you do list here, that's totally fine. It's not really an issue, but it's probably better to be specific because we know exactly what we're going to be doing. With the students here, we're just going to be using it within this method, so there's no reason to be general. It doesn't help anything. But class level variables, we don't entirely know how it's going to be used, so we can be a little bit more general and capture more use cases. All right, so what now? Let's go back and I want to explore the collection interface. So looking at Chrome, we have the interface called collection. The E, this here is the basis of generic programming, which basically means the E is going to be substituted, that's a hard word to say, substituted for a type. So in this case, we use string. So E is just like a placeholder. So don't worry about that too much. But what we can do is we can look through this and you can read all that beautiful text if you like, but I'm good. What I'm interested in seeing is this method summary, and these define the methods that you have to implement if you're going to be considered a collection. So the ArrayList will have all of these methods. The linked list is going to have all of these methods. That's because they implement the collection interface. It's a promise. Basically, they say, hey, I'm going to be a collection, and in exchange, I promise to implement all of these different methods. So one of these is add. You can add an element to the collection, which we've seen that. Looking at our code, we say students.add. That worked just fine. And there are a ton of other methods you can find here as well. We can clear out that collection altogether. We can check if the collection contains something, and so forth. Now there is something I want to talk about, and that is iterator. So I'm not sure we can get into everything in this video right now, but basically an iterator, it allows us to go through the collection one element at a time. So maybe I'll get into that next video. Now I want to take a break just to talk for a moment about two concepts you should understand in computer science, and that is the concept of a stack and a queue. So I want to explain these using illustrations. Imagine you're doing dishes and you put a bunch of plates on top of each other, a stack of plates. When you go to grab a plate, you grab off the top. So the one on the bottom just kind of sits there until everything else is gone. And you can explain this by saying first in is the last out. So you put the plate down first, and then you put a bunch of other plates on, you take all those plates off, and then it's out. So the first one in is the last one out, or FILO, first in, last out, FILO. Now the other way is a queue, and you can think of this as a line at a roller coaster. So if you're in line at a roller coaster for like 17 hours, you got like a huge line of people, and the person who gets in the line first is the first person to ride the ride. So first in, first out. So the first one, stack, first in, last out. Then the second one is a queue, first in, first out. So we got FILO and FIFO. And these structures are important because a lot of the complex data structures are based off of these concepts on how you get the data in and get the data back out. So we're going to talk briefly about queues, and specifically we're going to look at linked lists because you can use them as a queue. So up at the top of this interface collection, let's take a look at, I'm just going to search linked list right here. And you can see this implements dec. By the way, it's not deque, which that's how I read it at first, and queue. And if you pronounce it deque, it's probably not the end of the world, whatever. So to create a linked list, it's very similar to an array list, which we have done. So let's take a look at our code. And I actually want to change this a little bit. We're gonna just get rid of it, and we'll probably come back to something similar to that because I have this application in mind. But for now, I just want a little bit of practice with the linked list, and then we'll move on to the next step. So what we'll do is we'll create a linked list, and we're gonna have type string, and we'll just call it names. And this is going to be a new linked list of type string, and that is the syntax for that. And we can still add people to this list using names.add. And in here, let me zoom in just a little bit. We can put the name, so we'll add Caleb, names.add Sue, and then we'll do another one, names.add Sally. And we could take a look at the different methods for a linked list by just typing names dot, and we can scroll through here and see what our options are. Now, if we're going to use this as a queue, well, basically, think of a line. We put people in a line. We have Caleb followed by Sue followed by Sally. We need to basically have a way to say next and get that person, Caleb. So that method is actually remove, and it's going to retrieve and remove the head, the first element of this list. So it's going to retrieve it. So that's going to be returned, so we can grab that person. So we'll say remove, and let's just do a console, or wrong language, sys out, and we're going to put names.remove in there. All right, so when we run this, we get Caleb. So it takes that person off the queue and puts it in the console. If we do it again, we're going to get the next person, Sue, and then again, we'll get Sally. Run, we get Caleb, Sue, and Sally. If we run it a fourth time, oh, I don't like that idea. I think we're gonna get an exception. And indeed we do. No such element exception. So that is an example of using a linked list as a queue. You can also very easily use it as a stack. So my homework for you today is to do the research on how to use a linked list as a stack and try to implement it in our code. So thank you guys, stay tuned and don't give up. I actually took a couple days off, but don't tell anyone.